9.2 relative frequency. Probabilities can be estimated from experiments, and these probabilities are known as relative frequency. So remember, an experiment could be something like tossing a coin, where then the probability would be the number of times that you get a head. So if we were to toss a coin 4 times, you might get head, head, tail, and then head. And we'd estimate that the relative frequency of heads would be 3/4. To calculate the estimated number of times an event will occur, so if we are trying to figure out how many times it should occur in an experiment, what we do is we multiply the relative frequency by the number of trials. The more times we carry out the number of trials, so in my tossing a coin example up above, we did it 4 times and we got 3 heads out of 4. If I was to repeat that experiment and go up to 40 times or 400 times or 4,000 times, or if we had time even more than that, then we would expect that the number would be getting closer and closer to true probability. So in other words, a half. So in example 4, how many times would you expect to get a 4 if a normal dice is rolled 30 times? So to work that out, the expected number is going to be the relative frequency times by the number of trials. So the relative frequency for a 4 on a normal dice is 1 out of 6. So it's going to be 1 over 6 times 30. And there are any number of ways we could use to work that out, but a 6th of 30 is 5. So what we would expect is 5 times for number 4 to occur. Now we don't write it as 5 out of 30, we write it as just 5. Okay, so it's 5 times rather than 5 out of 30. Now will that happen in real life? Probably not. It might be more than that or it might be less than that. You might get it as well, but it's probably not really going to happen 5 times out of 30 rolls. John rolls a die 100 times and rolls 6 40 times. How many 6 should he expect to get if he rolled a die 400 times? Well, the expected number, again, is equal to the relative frequency times by the number of trials. So the number of trials was 400 times, and the relative frequency is the number of times that he scored out of the 100. So at the minute, he got 46s out of 100, and we need to multiply that by 400. So 1/100th of 400 would be 4, and 4 40s are 160, so then we would expect it to occur 160 times. Or another way to think about that is if it was 40 out of 100, then to get it out of 400, it would be 160. But the answer would be 160 times for that. Now, had we been doing this in a similar way to example 4, where we would expect a normal dice. So if it was a normal die, the expected number would have been a 6th times 400, and that works out 66 2/3, so really 67 times. So had it been a proper die, a fair die, then it would have been 67 times. But in this case, because we were told that the die was 100 times, or was 40 times out of 100, then we used that relative frequency rather than the true probability of it occurring. So if it were a proper fair die, we would expect 67 6s when we roll 400 times. But in this current die, we're not sure very much about it, but because it's 40 out of the 100, then it would be 160 times we would expect to see the number 6 whenever it was rolled 400 times.